Your remote MCP server requires authentication, but Claude Desktop only supports local STDIO connections. So how do you bridge that gap securely? We'll create an authenticated proxy server that forwards requests to your protected remote endpoint while maintaining the local STDIO interface Claude Desktop expects. You'll see how to wrap a BearerAuth-protected client in a FastMCP proxy, ensuring secure communication without exposing credentials in your configuration. From FastMCP, import FastMCP client. From FastMCP client auth, import BearerAuth. Hash create authenticated client. Client equals client. https://API example com/mcp/ssc. Auth equals BearerAuth. Token equals your access token. Hash create proxy using the authenticated client. Proxy equals FastMCP as proxy. Client name equals authenticated proxy. If name equals main. Proxy run. This demonstrates the proxy pattern for remote service integration, specifically creating a local bridge to authenticated HTTP endpoints. The concept transforms a remote API into a local STDIO-compatible service, allowing systems designed for local execution to interact with cloud-based resources transparently. What makes this distinctive is its ability to maintain the same interface contract while abstracting transport complexity behind a single proxy layer. The pattern works by establishing a bidirectional translation layer between local and remote protocols. Incoming STDIO requests get converted to authenticated HTTP calls, while server-sent events from the remote API are reformatted for local consumption, preserving the original tool contracts. This separation of transport concerns lets you keep your core logic unchanged while adapting to different deployment environments. This approach solves the common problem of environment mismatch between local-first tools and cloud services. It enables seamless integration with systems like Claude Desktop that expect local STDIO servers, while still leveraging remote APIs with authentication. The trade-off is minimal overhead for the proxy layer, which is justified when you need to maintain compatibility across different deployment scenarios without modifying existing tool implementations. Let's break it down line by line. From FastMCP, import FastMCP client. This imports FastMCP for creating AI-callable tools and client for establishing authenticated connections to the MCP server. These are the core components for building and interacting with FastMCP services. From FastMCP client auth, import BearerAuth. Imports the BearerAuth class for token-based authentication. This handles adding the authorization header with your access token, which the MCP server requires for authenticated connections. Hash create authenticated client. Client equals client. This instantiates the FastMCP client with authentication configuration. The client handles all low-level connection management, request signing, and SSE protocol implementation, abstracting away the raw HTTP streaming complexity. Without this, you'd manually implement OAuth flows and connection retries. https://API example com/mcp/ssc. This is the server endpoint URL for the FastMCP SSE, server-sent events, connection. It specifies where the client will establish its persistent event stream, enabling real-time updates from the MCP server. Auth equals BearerAuth. Token equals your access token. This implements bearer token authentication, the standard for API authorization. The token validates your identity with the MCP server, ensuring only authorized clients can establish connections. This is the preferred auth pattern for production FastMCP deployments. closing parenthesis terminates the client instantiation. This finalizes the authenticated client configuration before assignment to the client variable, ensuring all parameters like the URL and auth method are properly encapsulated in the object. Hash create proxy using the authenticated client. Proxy equals FastMCP as proxy. Client name equals authenticated proxy. This creates a FastMCP proxy instance that wraps the authenticated client, enabling real-time server-sent events communication. The proxy pattern here abstracts the connection details while maintaining the authenticated session, allowing seamless interaction with the MCP server. The name parameter identifies this proxy instance in logs and monitoring tools. If name equals main. This is Python's standard entry point guard. It ensures proxy.run only executes when this script runs directly, not when imported as a module. Without it, importing this file would unintentionally start the server. Proxy run. This starts the FastMCP proxy server, blocking execution to handle incoming SSE connections. Without this call, the proxy would initialize but never process events, defeating the purpose of real-time streaming. It's the required entry point for all FastMCP proxy applications. Authenticated client pattern. This FastMCP proxy setup demonstrates the minimal viable authentication flow, where a client connects to a protected server using bearer tokens without exposing implementation details. The token string is the only required configuration, but token expiration handling must be implemented separately for production use. This pattern maintains security while keeping client code remarkably simple.
The client that knows nothing about